Morning. Today we'll discuss about the first and second derivative method. We have seen the theory part in the last lecture. Now we'll try to solve the problem on first and second derivative method to determine the peak value of a signal and also to determine the impedance phasor. So coming to the outcome of this lecture, I hope that by the end of this lecture you will be able to apply this method, first and second derivative method, to determine the impedance based on given voltage and current signals. Moving ahead, a quick review of the formulae which we have developed in the last lecture. This is the equation to determine the magnitude of impedance, and this is the equation to determine the phase angle of impedance. Now, let's have a look at the problem. This is very similar to the problem which we have done for sample and first derivative method. Here, voltage samples have been given, current samples have also been given, the signal frequency has been given, and the sampling frequency has also been given. So it is very similar to the previous one. The only difference being here we need a first and second derivative for doing this type of things. Okay, so let us start this thing. So first of all, let me start with this V. It has been given as 110.838. It is 117.677. It is 120. And sampling frequency has been given as 1600 Hertz, which means that delta T is equal to 1 by Fs, which is equal to 1 by 1600. Right. So it is somewhere around 625 microseconds. 625 microseconds. Okay. So if I want to determine V dash, so what is V dash formula? It is the previous one, 117.66 minus 110.838 by 625 into 10 to the power of minus 6. Similarly, if I want this particular value here, so I must subtract this one here, 120 minus 117.677 by 625 into 10 to the power of minus 6. And for this one, I won't be getting any value because there is nothing present here. So if I solve this one, what is the value? Let me see. It is 117.677 minus 110.838 divided by 625 into it is 10,942.4. Okay. The next one is 120 minus 117.677 divided by 625 to it is 3716.8. So these are the V dash values. Now for this one, I am supposed to calculate a V double dash. V double dash also is the same. Just the only difference is that I will again go with this one. 3716.8 minus 10942.4 by delta T is again 625 to 10 to the power of minus 6. So for this value, I won't get anything because there is no value present here. So this is the value is minus 10942.4 divided by 625 divided by it is somewhere around minus 11,560,960. A very big value which I have got now. So yeah. So I will write them again. V dash, V double dash. V samples were 110.838, 117.677. It was 120. V dash for this case was 10942.4. It was 3716.8. Here there was no value. and here it was minus 11560,960, and here no value, and here no value. So I do have one complete set of values to determine my Vmax now. Okay. Similarly, I'll calculate for I. Now let's see for I now. My I values, it is 9.982, it is 8.492. So I dash is very simple. It is 9.982 minus 11.089 by 625 into 10 to the power of minus 6. Similarly, here it is 8.492 minus 9.982 by 625 into 10 to the power of minus 6. And here I don't get any value. So this value is somewhere around it is minus 177.2, and this value is minus 2384. So if I go with I dash, here I won't get any value, here I won't get any value. The top value will be minus 2384 minus 177.2 by 625 into 10 to the power of minus 6. Right. Minus of minus will become plus here. So it is minus 980480. So if I rewrite them, this is I dash, and I double dash. It is 11.089, it is 9.982, it is 8.492, it is minus 177.2, it is minus 2384. I don't get any value here. Here it is minus 980480. I don't get any values here. So this is a set of I values which I have obtained. So I'll employ these things to determine the impedance and also to determine the impedance value. Right. So first of all, let me calculate Vmax. It is equal to square root of V dash by omega whole square plus V double dash by omega square whole square. Right. So you know omega is equal to 2 pi f naught, which is 50 hertz in my case. So I'll get 314 here, the standard value. So V dash we have taken here 10942.4, 10942.4 by 314 whole square plus V double dash is 11560,960, 11560,960 minus by 314 square whole square. So this is my Vmax value. So let us try to calculate it now. So it is somewhere around, if I calculate it, I am getting 324 volts. This is Vmax. Similarly, if I go with the Imax, this is V dash, sorry, this is I dash by omega whole square plus I double dash by omega square whole square. So if I substitute the values, the recent values which I have got, this is I dash is minus 177.2 by 314 whole square plus minus 980480, right? It is minus 980480 minus 980,480 by 314 square whole square. So it is somewhere around 11.432 amperes. So now I have got Vmax and Imax. So now I can go with the magnitude of impedance, right? So the magnitude of impedance is Vmax by Imax. So I can directly divide it now, 122.324 by 11.432. Right, 122.324 divided by 11.432. I'll get a value of 10.7 ohms. This is only magnitude. Now, if I want to go with the angle of Z, we have seen minus tan inverse of. Let us recall the formula. This is the formula which we are supposed to use for determining the phase angle of impedance. So don't get confused. When I have said in the class, I might have used this minus inside. Now I am bringing it minus outside. So here minus outside, if I bring it, it will become minus into minus plus. That's the only difference. So minus tan inverse of, this is V double dash by omega. V double dash is 11,560,960. Right? 11,960,560 minus by 314 into what is V dash? V dash is 10942.4. 10942, yeah. 10942.4 plus tan inverse of I dash. I dash is 980,480, right? Minus 980,480 by 314 into I dash is minus 177.2 minus 177.2. Right. So now if I try to solve this particular one, I'll get 11,960,560 divided by 314. Times answer. It is 73.97 rupees. Plus is 60.43. So I'll get somewhere around 134.3 degrees. This is my value of Z now. Right. So this is the way how I determine the phase angle and the magnitude of the impedance. So please recheck the values again. If there are any numerical mistakes, you may get a different value. Okay, I have done in the calci, which I do have. If you do have a fast calci, then you can find any errors in this one. But I hope you have understood this mechanism of determining the peak value using first and second derivative method. Okay, so that's it from my side. We will solve more problems in the class now.